Good day. Today we're talking about the orders of reaction. But first of all, we have to know about the rate law. Now, the rate law for a chemical reaction relates the reaction rate with the concentration or partial pressures of reactants. So, for a generic reaction of A plus B that will result in C, the rate is given by R is equal to K, the concentration of A raised to X, and the concentration of B raised to Y, where R is the rate, the K is the specific rate constant, and the concentrations. Now, let's have two examples. We have 2NO plus O2 that will result in 2NO2. We have a rate, we have a specific rate constant, so the concentration of NO raised to 2, we got it from here, and the concentration of O2. For the second example, we have 2H2O2 that will result in 2H2O plus O2. We have a rate, we have our specific rate constant, so we will get H2O2 raised to 2. We got it from there. Okay, so let's start determining the orders of a reaction. For these example, we have 3 experiments and we have the concentration of A for the 3 experiments, same as well with the concentration of B and the initial rate formation of C for the 3 experiments. Take note that for experiments 1 and 2, for concentration of A, we have the same concentration, 1 times 10 to the negative 2. But for B, the concentration of B, it doubled. So we can take note of that for our solutions later. So we have a generic reaction of A plus B that will result in C, and we will have a rate law of R is equal to K, the concentration of A raised to X, concentration of B raised to Y. So we are tasked to find for the X and the Y, and if we add the X and Y, that will be the overall order. So let's start. So as I said a while ago, experiment 1 and 2, they have equal concentration of A, and in concentration of B it doubled, so we can use this. For B, we can use equation 1 and equation 2. So we will just write the rate law. For equation 2, we have the rate 2 is equal to K2, the concentration of A, and the raised to X, and the concentration of B, 2 raised to Y. We also have rate 1 is equal to K1, concentration of A, 1 raised to X, concentration of B1 raised to Y. Now, we said a while ago that the concentration of A in the first and the second experiment, they are equal, so we can cancel that, and we can also cancel the K. So we're left with B, the concentration of B, and the rate. So what we can do here is concentration of B2, concentration of B1 raised to Y. Now the rate for the first and the second experiment, rate 2 over rate 1 So rate 2 over rate 1, it is also doubled, so the result is 2. So for the rate, it is 2. And for the concentration of B, it is doubled 2, so that is 2 raised to y. Now we are looking for y, so if we equate that, y is equal to 1. Now we will take note of that, y is equal to 1. Next is that we need to find x. So to find x for a, we use, let's use equation 3 and equation 2, because for a, the concentration of B in experiments 2 and 3, they are equal, and in the concentration of A in the experiment 2 and 3, it is doubled. So let's use equation 3 and equation 2. Again, we will write the rate law, which is the rate 3 is equal to A3 raised to x, B3 raised to y, and for the equation 2, rate 2 is equal to A raised to x, B2 raised to y. Now, the B, they are equal, so we can cancel that out. So, again, we are left with the concentration of A. So, we'll divide that. So, rate 3 divided by rate 2, that is, if we plug in that to our calculator, we will have an answer of 4. That is 4. And here, the concentration of A, it is doubled, so that will be equal to 2 raised to x. Now, we are finding for x. If we evaluate this, x will be equal to 2. Now, let's take note again that y is equal to 1. So now we can write the rate is equal to k, the concentration of A raised to x, which is 2, and B raised to y, which is 1. So we can tell now that x plus y is equal to the overall order. So we can tell now that the overall reaction of this is, the overall order is 3. Now, if we are tasked to find k, look at here, k is equal to rate all over the concentration of A and the concentration of B. We just transposed it so that we can isolate k. So I will just use the experiment 1 for A and B. So they are both equal, so I'm going to just write that as k is equal to 1 times 10 to the negative 2. We have a squared and raised to 1, so this is understood also that it is cube root, and the rate is 1.5 times 10 to the negative 6. I'm sorry about that. So if we plug in that to our calculator, we will have a specific rate constant of 1.5, and the unit m negative 2s raised to negative 1. So we can write this as rate is equal to 1.5 m negative 2s negative 1, and A raised to 2, the concentration of B raised to 1. That's it.